be data transmission can be easily done. After that, we learned about port fasting. So port fasting is something which we do on the ports which are connected to end devices so that they don't participate in spanning tree elections. We do this to make sure that that we don't have to like know attacker in case in case if an attacker gets connected to the switch, so he or she cannot, so that attacker cannot influence the information or cannot make any changes on the device. That was something which we learned about for port fasting, and after that we looked into creating ether channels, right? So ether channels were connecting two switches over multiple links, something like this, and creating a group of these links so that they can act as one port, and STP consider them as a one virtual port instead of multiple links. So that was something which we discussed yesterday, and today which we have to the topic which we have to cover is ACL. ACL stands for access control list. So basically today we are going to discuss about ACL. ACL stands for access control list, and we use these lists in order to control the data transmission. When we talk about ACL, we have two types of list here. The first one is standard one, and the second we have here is extended. The standard one ranges from 1 to 99, and the extended one is there from 100 to 199. So if we talk about the standard access control list, these are applied nearest to the destination router. So we will understand this, how these are applied to the destination routers and how things work when we talk about ACLs. And then if we look into extended access control list, these are usually applied nearest to the source router. So as of now, you can keep in mind that there are two types, which are standard and extended, and standard ones are applied nearest to the destination router and the extended ones are applied nearest to the source router. Now, when we talk about these lists, what we do here is we just tell the router that, hey there, deny traffic from, let's say, a host which is 192.168.1.1. Then after that, you can say that deny traffic from 192.168.3.5. Let's say these are the IPs of some end devices, and you just tell the list that you don't have to accept any traffic which you receive from 1.1 or 3.5. Now, after these statements are done, like once you are done with these statements, there is something hidden which is implicit denial. So let's say a device 4.1 sends some traffic to the router. Now we have informed the router that you have to deny the traffic from 1.1 and 3.5, but which means that the router can accept the packet from 4.1, right? But when the list is made, the router will check the list and will see that, okay, I have to deny it from 1.1. Then after that, I have to deny it from 3.5. So we will look at the packet and we'll see that the packet is from 4.1. Now router will assume that I have to deny this as well because there is no such information about 4.1, right? You have not informed the router that you have to deny from 1.1 and 3.5, but if any packet you receive from 4.1, you have to permit that. Make sense? So you just have to inform the router that what you all have to permit. You are telling the router that 1.1 you have to deny and 3.5 you have to deny, but at the same time you have to also inform him or inform the router that these are the IPs from which you can accept the packets. Otherwise, the router will just deny everything. So now we will understand how we can configure an ACL on a topology. I hope this implicit deny thing is now clear to you all. If you have any doubt in this, let me know. Otherwise, we are good to move to the practical. Okay, I am repeating myself. So basically, there are two ACLs, standard ones and extended ones. We will look into them later on once we are on the practical. But after that, the thing is that you must have to understand how ACL work. So under ACL, you tell the router that, hey, you have to deny packets from 1.1. So let's assume there is a router connected to n devices and like this. These are the three end devices connected to the router, but you just don't want to make this PC communicate with this and this PC. So you will tell the router that, hey router, if you receive anything from this PC, you just have to drop that and you don't have to like share it to the others. So in such cases, we use ACL. And when you create a ACL list, you tell the router that you have to deny this, you have to deny this, or any other further detail which you want to tell the router. But after that, you also have to make sure that you inform the router that after all this, you have to permit the rest of them. Otherwise, what will happen here is if you tell him that you have to deny the packets from this PC, he will check the ACL list. So in case, even if this PC sends the traffic, let's say PCC sends some packet to the router, he will check the list and will see that, okay, we have to deny it from 1.1, 3.5. And if there is no information about what you have to accept or what the router has to accept, he will just deny everything. That's called as implicit deny. So if no information is there on in the list about accepting packets, the router will keep rejecting every packet which it receives. I hope it's clear. So you just have to make sure that once you configure or once you tell the router that these are the IPs you don't have to accept packets from, after that you have to also tell the router that these are the IPs from where you can receive the data. This will be more clear to you all once we are on the practical and once we configure the ACLs. So let's get to packet tracer now and understand how ACL works. Okay. We'll quickly create a topology of two routers. Yes, don't worry, this will be more clear to you now once you look into the practical. Add some end devices. Connect them together. Okay. Now we are going to use 1.0 here, 192.168 1.0 and 2.0 here. with 3.0 here. So we will go to router 0, go to CLI, say no, enable T, the interface with the IP, interface interface FA0/0 will be configured with IP address 192.168.1.1 at the subnet mask and no shutdown. Now we will configure the DHCP pool as well for the assignment of IP addresses to end devices. So IP DHCP pool A, then network 192.168.1.0 and at the subnet mask port router 192.168.1.1. Take an exit. Now we are going to configure interface FA01. IP address 192.168.3.1. Terminal, we will go to interface FA0/1, assign it the IP address 192.168.3.2, add the subnet mask. Now interface FA0/0. Now we are going to create the DHCP pool for network 192.168.2.0. You can exit. Desktop IP configuration and DHCP. So DHCP is working here. Awesome. So now we have successfully configured the devices and the interfaces with the IP addresses. Now let's quickly also configure routing on the routers so that the devices can communicate with each other. So we are going to use RIP. So let's configure the RIP version 2. We will advertise our directly connected routes, which are 192.168.1.0 and 192.168.3.0. Exit. Router number 2, we will the rep directly connected routes are 192.168.2.0 and 192.168.3.0. Okay. So let's quickly have a look at the routing table. And we can see that we have the routes with us. We have 1.0, we have 2.0 and 3.0 as well. So if you try to make communication between these devices, that will go successful, right? But the thing is now we don't want this PC to be able to communicate with these devices. So we just want that PC1 can communicate with PC0, but cannot communicate with the devices of network 2.0, which are these two devices, right? So in order to make that possible, we will use ACL. we will use standard access control list. Now, when we talk about standard ones, we know that we have to apply them nearest to the destination router, right? And if we see the destination router is this one, so we'll go to CLI of this router, go to the configuration mode, says host name router number 2, right? Now you have to run the command access list and assign it a number. Let's take 10. Now if you press question mark, you get a list of some prompts which you can use. So you have deny, permit and remark. So we just want to deny traffic of PC1, right? So we'll say deny and again press question mark. It asks you that is it a address or any source, any host or a particular single host. So we know that we have a single host which is PC1. So we'll type host, press again question mark, then you have to enter the IP address of that host. So we will quickly have a look at the IP, which is 192.168.1.3. We will write the same on this router. So we type 192.168.1.3, press enter, and that's all. Now you have created the list on this router, that you have informed this router that if you receive any packet from 192.168.1.3, which is this PC, just deny that packet. Now you also have to apply the access list. So basically you can apply I would say that one ACL interface direction. So what I mean through the direction and interface is, so tell me that if PC1 is sending some data to router 0, so and if PC1 sends some data to PC2, that data will go until router 0 and will enter through FA00, right? It will go inside FA00. Then after that, it will move outside of FA01. Then again, it will go inside of FA01 of router 2. Then outside of FA00 of router 2, and it will finally reach the destination. So I hope now the directions are clear to you how these things work. So basically every interface have two directions, inside and outside. So if we talk about particular data transmission, the directions can be understood through this. So let's say if PC0 is sending some data to PC number 3, the data will go inside FA00 on router 0, then outside FA01, then again inside FA01 of router 2 and outside FA00, and will finally reach PC3, right? So now you can assign or you can apply one ACL on one interface and per direction. So basically you can create some ACLs and after that you have to apply them. Now we don't want PC1 to be able to communicate with these two devices, right? So can I say that I can apply the ACL on FA00 for the outside direction? Quickly let me know in the chat that is it correct or not. Okay, so if we apply the ACL on FA00 for outside direction, the data from PC1 will go to router 0 and after that will reach router 2. But when it comes to taking an exit from FA00, that won't be possible, right? So we'll quickly go to interface FA00 and after that you say is group 10. You are just applying the access list which you have created. Press OK. Now after this you have to tell the direction. So if we talk about FA00, the direction will be outside. So we'll type out. And that's it. You have successfully applied the ACL. Now, if you try making communication between PC1 and PC2 or 3, it will go failed. And even if you retry it, it will go failed. Now, if you try so it satisfies our requirement, right? We wanted PC1 not to be able to communicate with these two devices. But if we try making communication from PC0 to, let's say, PC2, it's also going failed because of the implicit deny thing which I told you about. We inform the router that, hey, you have to deny, you have to deny data from 1.3, but we didn't tell him that you also have to accept the data from other PCs. So in order to do that, you also have to make sure that you run the command of permitting data. So we will again go to our access control list, which is access list 10, and we will say permit any. So like permit any. And once you press enter and have a look at the access list, you can see that there is one list created which says the first statement is deny host 1.3. Then after that, it says that permit any, and this 1020 can be considered as a sequence. So you are telling the router that deny 1.3, but permit any, which means that if there is anyone else, who is trying to send some data, you can permit that. Now we will try again making communication from PC0 to PC3, and it goes successful, right? We can try this again. So it's successful, but when you try from PC1 to PC3, it's saying failed. We have successfully satisfied the requirement, which was that PC1 shouldn't be able to communicate with these two devices, and PC0 is now being able to. So I hope now implicit thing is also clear to you, and the configurations of ACL as well. Let me know if you have any doubt in this. Okay, great. So I'm writing the commands here. Uh, After that, you can try this out in at your end. In order to create the ACL, and will be access list 10 and then deny, then the IP of the host you want to deny. In our case, it was 1.3. Then if we look at this, this is the command. So you also have to tell whether it is a host or a network. So before this, you have to type host and then the IP address. This successfully creates the ACL. You can go step by step by using the question mark. This will also help you to understand this more clearly. Once the ACL is created, select the interface. Go to the interface configuration and apply it using the command IP access group. And the direction. That's all. Take your time, try this out, and let me know once you are done with this. I hope everyone is done with the practical. Okay, so let me know if you are still on it. I will wait for a few more minutes. Okay, it seems like everyone has completed the practical. Now we will understand how we can block a whole network. So we will quickly add another network under router number 0, and we will try blocking that network. So add one more switch to this configuration, to this topology, add some end devices and connect them with router 0. All right. So now we have to turn the router off in order to add some modules. But before that, we will run the command to save our configuration. So you run command write to make the configuration saved in the router. Okay, so we run the command write to save the configuration, and now we can see if we will try adding some modules, and let's see if the configuration comes up. So if you try looking at the routing table, you will find that configs are still there. So in order to save the configuration on devices, you can use the command write write. Now we have successfully added the module to the router, and now we will connect these with switch, and after that with these end devices. Let's configure a network of 192.168.4.0 here. We'll go to interface Ethernet 1/0. Okay. Assign it the IP address 192.168.4.1. Add the subnet mask and no shutdown. Now we will configure the DHCP pool here. The network 192.168.4.0, add the subnet mask and the default router IP 192.168.4.1. Take an exit. Okay, so now we will move back to our router number 2. And if we look at our access list, so it tells that we are denying the traffic from 1.3 and we are permitting the traffic from any other device except 1.3, which is permit any, right? Now what we are going to do here is we will just delete this whole configuration of access list 10 using the command no access list 10. Now, if you take a look at show access list, there is no information, right? So we deleted the configuration of this access list number 10. Now we are going to create another list in order to block traffic from the whole network 4.0. So we will say that access list 10 deny. Now you have to add the network ID, which is 192.168.4.0. Now you have to add the wildcard mask, which is 0.0.0.255, and we are done. We'll go to interface FA 0/0 and apply the same at that end. Okay, add the direction and we are done. So basically, we have informed this router that, hey, you don't have to accept any data from the network 4.0. So let's try pinging from device laptop 0 to PC 3. It goes failed. And one of the reason of this data being failed is that we still have not added the network in the routing protocol configuration, right? So we still have to advertise that as well. But router rep version 2 network 192.168.4.0, and even after configuring the routing of network 4.0, if you try making communication between these devices with these devices, it will go failed. Whereas if you try making communication between these devices, it will go successful. Make sense? So the configuration we have made was for blocking the whole network, which is 192.168.4.0 for these devices. Take 10 minutes more and try this as well, and let me know once you are done. After that, we will look into extended access control list. Sure, I am repeating myself. So in the last scenario, what we did was we denied PC1 data, right? We told the router that, hey, you don't have to accept data from PC1, which is with the IP address 192.168.1.3. But now we are telling this router that you don't have to accept data from any device which is connected to network 192.168.4.0. In order to do that, we use the command access list 10 deny. Then after that we added the network id, which is 192.168.4.0, which is that you don't have to accept, you have to deny data from devices connected to 192.168.4.0. After that, add the wildcard mask, and that's all. So let me just write this command for you. I interface FE00 because we don't want 4.0 to be able to communicate with these devices, right? Since we are, as of now, we are looking into standard ACL, we'll be applying that to destination routers. That's something which was cleared in the very initial time of the class, right? So since we are using the standard list, we configure it on the destination router. And the destination router is router 2. Now pay attention that we want 4.0 to not be able to communicate with this network, right? And in order to do that, we have to apply the ACL on FA0/0, because any data going from laptop 1 will go to this router, then after that will go inside FA01, and then in order to reach 2.0, it has to take an exit from FA0/0, which means outside of FA00. Now uh, imagine that there is this whole network with a router and some end devices, which is now connected using this router. And if you apply ACL on to accept data receiving from 4.0, and in case that that data is supposed to be for this network, which is, let's say, 192.168.5.0, that too will be rejected by the router because it is not even accepting the data inside it. So you have to always make sure that you are assigning the ACL nearest to the destination. I hope it is clear now that why we have always applied the ACL on FA0/0 and not inside FA0/1. Great. Now take your time and try blocking this 4.0 for 2.0, and let me know once you are done with the practical. Okay, I hope everyone is done with the practical and we are good to move towards extended ACL. Okay, so now let's understand how extended ACL works. So before moving to that, let me just quickly delete the configurations about extended ACL. So we'll go to router number one, go to the configuration mode, say no access list 10. Also remove it from FA00 by saying no IP access group 10 and the direction out, right? Now we have successfully cleared the access list, and now if you try making communication, it will go successful. You see, laptop 0 to PC2, it says successful. So this was all about standard ACL. Now we will move ahead towards uh, extended ACL. So as we discussed before, extended ACLs are usually applied on the router nearest to the source. So we'll be applying ACL on this router. That's very clear to us as of now. So we'll go to router 0. And before that, let me configure telnet on this device. So I'll say enable and conf p enable password. I'm setting a password to make the device into enable mode, which is enable password. So I have set the enable password as Cisco. You can try that out. Let's see if that works or not. But I would say the traditional way or the very basic way to configure ACL is using the commands which were shared. And even if you try pressing the question mark after the command to like complete the command, you will see the same details there as well. So you can try. That's not a bad thing, and that won't cost you even. So try experimenting with the commands and topologies that will make you learn far better than any I would say any class. So when you try yourself, you learn the best, right? So now we'll look into extended ACLs, and we have successfully, as of now, we were just configuring telnet on the device, and we have set the enable password on router 0. Now we'll run the command line vty, which we use for configuring telnet 0 space 4, which means we are creating some virtual lines, which is numbering from 0, 1, 2, 3, and 4. Now, this means that at a point of time, 5 people can uh, use telnet to configure the router 0. After this, once you press enter, you have to set a password. So we will set Cisco again and then say login. Take an exit. If you try configuring the router 0 using a laptop, we go to command prompt, say telnet 192.168.1.1. So it asks you for the login password, which is Cisco. Then you are in the interface of a router. You say enable. Now you have to write the enable password, which is again Cisco. And from here, now you can like configure router 0 remotely. Now we will be using extended control list to we just want devices from network 1.0 to be able to configure router 0 over remote access. We don't want that any PC from network 4.0 or 2.0 can configure the router 0 using telnet. But if you try this as of now, it will go it will work fine with these devices as well. So 192.168.1.1, and I am able to configure the router using a device from 2.0, right? But we want that these device cannot like remotely control the configurations of router 0. So we will go to router 0, go to the config mode, and we are going to create a access list one. As I said before that, or you can say any number above 100 can be used for extended control list. So let's take 110. Then after that, you say permit. Now, if you press question mark, you will see a list of protocols, right? So if we talk about telnet is a TCP protocol. So we will say TCP, press question mark again. Now it asks you for the source IP or source address. So we want devices of 1.0 to be able to like create telnet sessions, right? So the source IP will be 192.168.1.0, and add the wildcard bits 0.0.0.255. And if you press a question mark again, now it asks you about the destination address. So tell me in the chat that if I try using telnet using the IP 4.1 for this router, would I be able to make the remote session or not? Yes. Similarly, if we use 1.1 or 3.1, we'll be able to make the remote session using telnet. So the destination IP is 192.168.1.1, then 4.1 and 3.1 as well. So we have to add the information about all three IPs. So we will start from 192.168.1.1, and if you press question mark after that, you can add the wildcard bits, or even if you don't want to, you can move ahead here after this as well. So 192.168.1.1, then say equals to 23, which is the port number of telnet. So you have to tell that which protocol you are going to configure this access list for. So press enter. Okay, just a minute. Okay, let me try this again. It says that the input is invalid. So let's use the wildcard bits as well and press question mark after this. Okay, so you have to add the wildcard bits for destination address as well, and after that you will say equal, or you can use the EQ as a abbreviation, and after that you can add the port number. So we know that we use 23 for telnet, right? Press enter. So this is the command, this is the whole command which we are using. So basically we have created the access list 110. Then after that we said that permit TCP protocol from the source address 192.168.1.0. This is the wildcard mask. Then the destination address 192.168.1.1. Then again the wildcard mask. Then we have informed about the particular protocol, which is telnet, right? Now we will run the same command for 192.168.4.1 and 3.1. Take an exit. Now we have successfully informed the router 0 that, hey router, you only accept telnet configuration or telnet sessions from 1.0 on IP 192.168.1.1, 3.1 and 4.1, right? but we have not said as of now uh, that you have to deny from these as well, right? So whenever you create a access control list, it starts denying data from others as well because of implicit deny, right? So we have to inform him that you can accept data from others, for which we will use the command access list 110 permit. Now we will tell him about the protocol, which is ICMP. Then any from any destination or any source to any. Make sense? Press enter. Take an exit. And now if you try making telnet sessions using this device, it might not work. So we'll say telnet 192.168.4.1, and okay, I'm still able to create the session. You see that connection to, okay, right? Yes. Thank you, Sunam, for reminding me that we still have to apply it to the interface, right? So we will go to interface FA00 and we will say that IP access group 110. Now the direction will be in, right? Because it will receive it inside FA00. So press in and then that's all. Now if you try creating telnet sessions, let's see if it works or not. Telnet 192.168. Uh, Seems like we have made some error in the configuration. Let me quickly check this out. Okay, so if we look at our configuration, we added the wildcard bits, and because of which the router considered it as network. If you see that we configured 1.1 for the destination IP, and in the details, when we look at the show IP access list, we can see there is 1.0. So it is considering the whole network. So because of this, we are still able to make telnet sessions using devices of 2.0 or 4.0. So we will go and go to the router again and we'll particularly deny it for the host, or particularly for 1.1, 4.1 and 3.1. So let me quickly repeat myself on the configurations, and I am just quickly configuring the access list again. So before that, let me delete the access list 110. Now we don't have any information and do show access list. Now we'll say access list 110. Okay. Permit TCP. Permit TCP for the network 192.168.1.0, right? We can like accept from all the devices of 1.0 and add the wildcard mask 0.0.0.255. Now press question mark. Now we have to select host. Since we have to use a particular IP, we'll be choosing host. and after that add the IP 192.168.1.1. Now you don't have to again press the enter the wildcard mask, since there is a particular IP, and the command will go same like equal to 23, just like before. I hope now it's clear to you all what was the error and how you have to configure the command. So press enter. Similarly, make the configuration for the other interfaces, which is 4.1 and 3.1. Now we will tell the access list that ICMP from any source to any destination. Exit. Now let's see if we are able to make telnet sessions using these devices. Telnet 192.168.1.1. Oh, we still have to apply it to the interfaces, right? So we'll go to interface FA. We have already, I guess, applied it on interface FA00. Let me take a look at that. Show run. So if we check the details, we can see interface FA00 already have it, IP access 110 and IP access group 110 in. Now we have to apply it on interface Ethernet 1/0 and FA0/1, right? So we'll go to interface Ethernet 1/0 and say IP access group 110 N, interface FA0/1, IP access group 110 N, and we are done with the configuration. So it was a bit, we got confused in between, but I hope it's clear to you all now. Let me know if you still have any doubt. I'm writing the commands here. So the first step is creating when it comes to creating extended ACLs, you have to select a number from 100 to 199. So we selected 110. Then after that, you say permit TCP from 192.168.1.0 at the wildcard bits 0.0.0.255 and destination IP is 192.168.1.1. Then you say equals to 23 for the telnet particularly. Now if you see the command, it looks like something this. Then the command for 2.1 and for 4.1 as well. Now you go to interface FA0/0 and say IP access group 110 N. Similarly, on interface Ethernet 1/0, you say IP access group 110 dot. Then on interface FA0/1, again the same command. Now make sure you tell the router that you can accept data from other devices, and you will run the command access list 110 permit ICMP from any host to any device. And if you try making telnet now, hopefully I, I guess it will not work, because now the configuration is all correct. And if you see it, it says that trying 192.168.1.1, and after some time you will see that the connection is failed. It timed out, right? And similarly, if you try from PC2, which is there from network 0, it will again get failed. So you can try it out using any IP of router 1, be it 192.168.4.1 or 1.1. Every time it will get failed. So please let me know if you have any doubt in this. I can repeat myself again. I know we made some confusion in between, and but after that, I hope you guys were also able to troubleshoot the issue, because we used the wildcard mask. The router considered this address as a network and was still able to make telnet sessions under this network. Okay, just tell me that, are you guys able to understand why we were still able to make communication or make telnet sessions under the using these devices when we configured the ACL before? So what we did basically was, uh, after this IP 192.168.1.1, we added the wildcard mask, and because of which the router considered it as a network ID. And even after the configuration, these devices were able to create telnet sessions. But after that, we corrected our mistake and reconfigured the ACL using the correct commands. So basically, we created a access list 110, and after that we said permit TCP, because telnet is a protocol of TCP. We said that permit TCP. Then it asks you for the source address, and we wanted PC connecting 1.0 be able to create telnet sessions. So we said that 192.168.1.0, added the wildcard mask, and after that it asks you for the destination. So destination IPs which are there to create telnet sessions on router 0 are 192.168.1.1 for FA00, then 4.1 for Ethernet 1.1/0, then 3.1 for FA0/1. So we created the configuration for all three IPs, and after that you just have said equals to 23, the port number of telnet. So you are telling the router that we are doing this for the telnet particularly. Make sense? Now, once the access list was successfully created, you said that now in order to that there is implicit deny on all types of ACL. So if you don't put the command access list 110 permit ICMP any to any, it will not accept data from these devices. So if you miss this command and try pinging from laptop 1 to the router, it will just deny data. So you have to tell that, hey there, you can accept the data, but make sure that you accept the telnet sessions from 1.0 network only. Then after that, we applied the ACL on FA00, because devices from this interface can create telnet, right? Then we applied it on Ethernet 1/0 also, and FA01 also. Okay, when it comes to in and out, if we say that PC1 tries to create telnet session, tell me the data will go inside FA00 or outside FA00.